We are looking at question number 46 of ECE Set 1 K 2017 question paper. The question is, a finite state machine is implemented using two flip-flops A and B and a few logic gates. So the possible states for QA and QB are 0, 0, 0, 1, 1, 0 and 1, 1. Xn is held at a constant logic level throughout the operation of FSM. QA and QB are initialized to 0, 0 and clocked. After a few clock cycles, which of the given statements are true? For concepts related to this question, you can refer lecture 24 named as Finite State Machine Design, handled by Professor D. Roy Chaudhary in the course Digital Systems Design from IIT Kharagpur. So some of the concepts related to this question are the behavior of a D flip-flop. So every clock pulse, the output Q gets the value of input D, and you'll also need to know behavior of some basic logic gates. Here in specific NAND and XOR are used. Moving on to the solution for this problem. So let us analyze this circuit. We see that at every clock pulse, QA gets DA value, QB gets DB value. And how is DB generated? It is NAND operated with QA and Xn, and DA is generated by XOR operation of QA and QB. With this analysis of the FSM, let us tabulate the results at the end of each clock cycle. Note that in the question it is mentioned that Xn is kept at a constant logic. So let us tabulate the results when Xn is equal to 0 and when Xn is equal to 1. Initial state of QA and QB are mentioned to be 0, 0, which implies Q bar A is 1 and Q bar B is 1. And DA is QA XOR QB, which is 0 XOR 0, which is 0. And DB is NAND operated Xn with QA, which is 0 NAND 0, which is 1. So clock cycle 1, D of clock cycle 0 goes to QA, and therefore QA is 0, Q bar A becomes 1, and Xn is held at 0. D is 0 NAND operated with 0, which is 1, and QB is 1, Q bar B becomes 1, 0. And DA is nothing but QA XORed with QB, which is 0 XOR 1, and that is 1. In clock cycle 2, D at the end of clock cycle 1 goes to QA, that is 1, and Q bar A becomes 0. Xn is held at 0. DB becomes Xin, that is 0. NAND operated with QA, which is 0 NAND 1, that is 1. And QB is previous clock cycles D, that is 1, and Q bar B is complement, that is 0. And DA is nothing but QA XORed with QB, which is 1 XOR 1, that is 0. In clock cycle 3, we see that A becomes 0 and Q bar A becomes 1, and DB is 0 NAND operated with 0, that is 1, and QB gets 1, Q bar B becomes 0, and DA is QA, that is 0 XORed with 1, that is QB, which is 1. And at the end of 4th clock cycle, we see that A gets 1, QA gets 1, Q bar A gets 0, Xn is 0, and DB is 0 NAND 1, which is 1, and QB gets previous cycles D, that is 1, and Q bar B is the complement, that is 0, and DA is 1 XORed with 1, which is 0. We see that clock cycle 2 and clock cycle 4 are exactly the same. Let me highlight this for you. Clock cycle 2 and clock cycle 4 are exactly the same. So this will continue to repeat in the future. Now let us see what happens in the case of Xn equals 1. So the initial state is the same as previous, and now in clock cycle 1, QA gets previous clock cycles D, that is 0, Q bar A is the complement, that is 1, Xn is always held at 1, and D is Xn NAND operated with QA, that is 1 NAND 0, which is 1, and QB gets previous cycles D, that is 1, and the complement goes to Q bar B, that is 0. DA is QA XORed with QB, which is 0 XORed with 1, that is 1. In the next clock cycle, QA becomes 1, Q bar A becomes 0, Xn stays at 1, and DB is 1 NAND operated with 1, which is 0, QB gets 1, Q bar B gets 0, and DA is 1 XOR 1, which is 0. In the third clock cycle, QA gets 0, Q bar A becomes 1, and DB is 1 NAND operated with 0, which is 1, and QB gets 0, Q bar B becomes 1. DA is QA, that is 0, XOR with 0, which is 0. At the fourth clock cycle, we see that QA gets 0, Q bar A becomes 1, DB is 1 NAND operated with 0, which is 1, and QB gets 1, Q bar B becomes 0, and DA is 0 XOR 1, which is 1. Let us now analyze what the states of QA and QB are. Here we see QA, QB is 0, 1, becomes 1, 1, then becomes 0, 1, and again becomes 1, 1. So QA and QB are going through 2 of the 4 possible states when Xn is equal to 0. Now, when Xn equal to 1, we see QA is 0, 1, QA, QB are 0, 1, then becomes 1, 1, then becomes 0, 0, and then again becomes 0, 1. So QA and QB are oscillating through 3 possible states out of 4 possible states. So the correct option here is that when Xn is 0, QA, QB cycle through 2 of the 4 possible states.